Hello everyone, I am Aisha Siddiqa Meem, a final year student of Computer Science and Engineering at East West University, Bangladesh. I am going to explain the understandings of mine from the given mesh problem and its solution, which is taken from the course CS50 offered by Harvard, which is implemented in Python. So all of you already know about the mesh problem, but I'm going to tell a little bit about it. The mesh problem is a game in which a person starts from a start state and ends up in a state which is a destination state. The person has to go through a sequence of paths for finishing the game. So I'm going to go through the code and explain my understanding. So we can see it import SYS, which is a module in Python. Then a class node is defined, which keep tracks the state, parent, and action. The parent state comes before the state because it is the initial state. Um, the init function will come every time when we want to create an object from a class. Then the stack frontier class is defined here, where initially and frontier is created as an object which is represented using list, which will contain the set of all frontiers. If I talk about frontier, it is a combined path of all initial segments which will build up from the initial state to the goal state. Then the add function will add something to the frontier by appending it to the end of the node because stack uses last in first out method. Then the contain state will check if the state is in a if the particular state is in the frontier or not. Then the empty function will check if the frontier is empty or not. If the frontier is empty, the length of the frontier will be 0. Then the remove function will check if the frontier is empty or not. If the frontier is empty, nothing can be removed from the frontier. So there an exception will be raised and return the output empty frontier. If the frontier is not empty, a node that is added in the last will be removed from the frontier because as I've already said, stack follows the last in first out method. So the last thing that added to the list will be removed from the frontier, and that's how the frontier will be updated and the node will return as a result. The class Q frontier is exactly the same as the stack frontier except one thing. Stack frontier removes the node from the end of the list, but the Q frontier will remove the node from the beginning of the list because Q follows the first in first out method. So the first thing that added to the list will be removed from the frontier. That's why it represents 0, which represents the first thing that added to the list. And in the stack, there were the representation of -1, which represented the last thing that added to the list. So here is the main difference between queue frontier and stack frontier. So the class Maze will tell us the process of the sequence of Maze using a text file, which will be given it as the input. So here we can see it is taking the file name and reading the file name and keeping it to the contents. Then it checks the validation of the start node and goal node, as there can be one start and one goal node. So it is checking that if there is more than one or not equal to one, it will raise an exception. Then the height and weight of the mesh is determining by the length of the contents. This part of the code keeping track of the wells. This part of the code printing the solution. The star sign is for the path of the solution from the start node to goal node. When we will run the code, we will see A is the start node and B is the destination node, and the path will be designed with star marks. Then this part will show us the result, and let's come to the solve part. This part will find a solution, will solve the mesh problem. Actually, the self number explode is for keeping track how many states as has been already explored, which is initially 0 as anything has not exploded yet. So here's start is the initialization of the frontier, and the frontier we are taking the stack frontier as the frontier, so we are using depth first search because depth first search use stack. Then the empty the self explode is set is empty here because nothing is explored yet, as I have said. So here's a loop where if the frontier is empty, there will an exception raised, which will return the no solution. But if the frontier is not empty, then a node will be removed from the frontier, and as a state will be explored from this part, so the number of explode will increase by 1. Now this part will check if the node is goal state or not the goal state. If the node state is equal to goal state, then the actions and cells will build up using a list. In this part of the code, the parent the parent is not known here because it will backtrack its way to define the actions that has been taken to come to this part. As in the parent state there is no before state or explore state, that's why the node parent is not known here. Then it will take build up the actions and cells, and it as we are backtracking, that means we are going from goal node to initial node, we have to reverse the actions and cells. So here's the actions and cells reverse, which will come to the solution, which comes as the solution and returning the solution. The explode state will add to the node state. Now we will check if the action state is in the neighbor state or not. We have talked about if the node state is equal to goal state, but if the node state is not the goal state, then it will be added to the explode state. So for each neighbor, we will check if the state is in the frontier or not. If the state is in the frontier, then it's okay. But if the state is not in the frontier, then it will head it to the frontier as child node. So here comes the output and the solution. How we will print the solution and the number, and now we're going to run the problem. We have 3 text files. I'm going to run the second text file. So sorry for the incorrect spelling. So I screen. So we can see here it is the maze and the solution is here. As we have used stack which means we used the DFS, depth first search. The states explored is 194. 194 state was explored, and as you can see, A is the start node, B is the goal node, and this is how the path is going as the solution. So if we want to do the solve the problem in DFS, not DFS, in the BFS, then we have to give the fronter. We have to change the fronter actually. I am showing it to you how you can do that. You can see we have taken the stack fronter. So I am using the queue fronter, and now I'm going to run, and I'm going to give the same problem but in BFS, not DFS. Okay, now you can see this is the same problem that we already explored in DFS, where the explored state was 194, but the explored state here is 77 and the same path. So you can see that DFS is not optimal as BFS. BFS is uses more technical ways than DFS. That's why it's explored. It has explored less states than the DFS. So that's how the code works. That's what I have understand from the code. Thank you so much, everyone. Thanks for watching.